welcome to Electrons. Electrons are fermions. That means that they're not bosons. So they belong to a family that also includes the neutrinos, which is called the leptons. They're not just fermions, they're also leptons. We know they're subject to the uncertainty principle because they are existing, so it's said, in a state of superposition all the time. The Pauli exclusion principle says that electrons cannot occupy the same shell valence within the atom at any particular time. They all have to have a separate position in space-time, according to the Pauli exclusion principle. Now, as the uncertainty principle has recently enjoyed some extension and become the extended I think, uncertainty principle, could the Pauli exclusion principle potentially be subject to the same kind of treatment? Is there more to the electron than currently meets the eye? They are negatively charged particles, and they have an opposite number, which is the positron, which is positively charged. Electrons are suspected to be in superposition at all times until they are observed, and they make up the majority of everything. In fact, definitely everything that we can perceive, touch, and interact with in our universe. Its physics symbol is an E minus, because it's negatively charged. And it exists outside the nucleus of the atom. It surrounds the core. You've got the neutron and the proton in the middle here. Then you've got electrons around it. Somehow. They used to think that they orbited the nucleus of the atom, but then they found that they don't really orbit. They're fuzzier than that. And they spin. Electrons, they spin and they're fuzzy. They have an opposite number, which is symbolized by an E plus, and that's a positron. When a positron appears in this universe, it's immediately annihilated, poof, by an electron. But the question is, are the electron and the positron actually two sides of the same coin? Superposition is what all particles are now said to be under. They are all superpositioned, apparently. And that means that everything is existing in two states at once. Two states at once means two variants of ways in which to occupy space-time. So we could say that what you're doing now and what I'm doing now is one position, but there is a superposition in which we're doing something different. So electrons are the same. And the positron, which comes in, annihilates with an electron and gives so much energy, is its opposite number. Together with its positron partner, of course, the electron is subject to some debate because it has this thing called angular momentum, spin, in other words, spin up or spin down. An electron can be in one or the other, or both of those states at the same time. And how you measure the angular momentum of a particle that you can't see, I don't know. You have to go and find that out because I haven't got the answer to it. Anyway, not having the answers to everything in life is all part of the mystery, and the magical mystery tour that we're on is discovering more about quantum mechanics and how it relates to us. So don't forget to be around for Series 3 when it happens. I hope you thoroughly enjoyed this video, and thank you very much for watching. I look forward to your comments, and of course I would like to see you everywhere else: Facebook, Twitter, websites, wherever you find quantumology and want to explore. And in the meantime, take care of yourselves, enjoy your journey, and I'll see you soon. Take care. Bye.